Welcome back. Today we'll solve problem 12-43. And this problem is taken from chapter number 12, Deflection of Beam and Shaft, and book name is Mechanics of Material by RC Hibbeler. So statement is determine the equation of elastic curve EI is constant. So you can see this beam, there is a pin support at point A and there is a roller support at point B. At this end we have 4 kips load, and at this point we have a moment 6 kips into feet, and this is also 6 kips into feet, that is clockwise. So we have to determine the equation of elastic curve, and we'll solve this question by using Macaulay's method. So let's start with the solution. So first step is that if you remove this roller support at point B, so you will be having a reaction force, let this is RB, and if you remove pin support at point A, so you will be having a reaction force in horizontal direction which is RAX, and there will be a vertical reaction which will be RAY. We have taken RAY as downward, so you can take it upward as well, and from then its answer you will define that whether you have taken the corrected direction or not. So we'll find this RAX and RAY and RB by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0, and taking this direction is positive. So you can see only horizontal force is RAX and there is no other force, so I will write RAX is equal to 0. So it means the reaction horizontal reaction force is 0. Now we'll find another RB by using equation of equilibrium, that sum of all moments about point A is equal to 0, and taking the counterclockwise moment as positive. So about point A, the first moment is this one which is 6 kips, that is clockwise, so it will be negative. Next is this one which is also clockwise, it will be negative, and the third moment which will be 4 into perpendicular distance is this one which is 24, and this is also clockwise, so it will be also negative, and the last moment which is produced by RB into perpendicular distance is 24, and this is producing counterclockwise, so it will be positive. But the sum of all moments about point A will be 0. So I will write minus 6 minus 4 into 24 plus 24 into RB is equal to 0. So minus 12 and minus 96 plus 24 RB is equal to 0. So 24 RB will be equal to 108. And when you calculate, divide 24 on both sides, so you will get RB will be equal to 4.5, and the unit will be kip. Now you can find RA as well. So for that I will write another equation of equilibrium, that sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So one force which is RAY, that is downward, so I will write minus RAY minus 4 kips, that is downward, and plus RB which is 4.5 is equal to 0. So from here minus RAY plus 0.5 is equal to 0. So RAY will be equal to 0.5 kips. So our answer is RAY is 0.5 kips, that is positive, and we have taken it as negative in downward direction. So it means that our direction which we have chosen downward is correct one. Now you have RA, RB and RAY, so you can move toward finding the equation of elastic curve. So for that we know that equation of elastic curve can be obtained by using this equation, EI into d square V over dx square, where x is the length, let's start from here, you can see, and V is deflection at any length of x. So this is the equation. So we will find this moment. So what we will do, we will start from the left hand side and we will move toward right hand side, and by using Macaulay's method we will neglect the terms on the right side which is 4 kips and RBY. Now you can see at point A we have a point load, so the point load case is this one, loading is this one, and here you can see if P is applied at a distance of A, so moment equation will be this one. Since if A is equal to 0, so moment function will be equal to P into x minus x power 1. Okay. And this P is upward, so the moment equation is positive. So here the RAY is downward, so I will write minus RAY is 0.5 kips into x minus A. So A is equal to 0 over here because RAY at point A. So what we will do, we will write x minus 0 power 1. Now we have a moment, this moment which is 6 kips into feet, so moment case is this one, and function for the moment is this. Clear? And here this is A will be equal to 8 feet because this moment x at a distance of 8 feet from the origin. So I will write, and the moment is downward, so this is positive equation, so I will write m0 is 6 into x minus 8, and its power is shown as 0. The other moment is this one which is 6 kips, so same 6 into x minus, now total distance for A will be equal to 16. So this is the total distance because moment x at a distance of 16 from the origin, 16 feet. So I will write x minus 16 power 0, and we will neglect RB and 4 kips as well. Okay, so this is your moment equation, and let this is equation number A. So what we will let put value of m in equation A, you will get EI into d square V over dx square is equal to minus 0.5 times x plus 6 into x minus 8 power 0 plus 6 into x minus 16 power 0. So what we will do is that integrate this equation, you will get EI into dV over dx is equal to minus 0.5 x square over 2 plus 6 into x minus 8 power 1 divided by 1, which is 6, and 6 into x minus 16 power 1 divided by 1. And there will be a constant of integration C1. Let this is your equation number 1. Now integrate equation number 1 again, so you will get EI into V, which is deflection, is equal to minus 0.5 x cube over 2 multiplied by 3 6 plus 6 into x minus 8 power 1 power 2 divided by 2 plus 6 into x minus 16 power 2 divided by 2 plus C1x plus C2. If you further simplify it, you will get EI into V is equal to minus, we can also write it as 0.25 divided by 3. If you divide both numerator and denominator by 2, so you will get this, plus 3 into x minus 8 power square plus 3 into x minus 16 square plus C1x plus C2. Let this is your equation number 2. Now C1 and C2 are unknown constant of integration. So by using boundary conditions, we will find C1 and C2. So what are the boundary conditions? So I will write it. So first boundary condition is that at x is equal to 0, we have deflection is equal to 0. So let me show you over here. You can see here x is equal to 0, deflection will be equal to 0 because there is a pin support. Okay, so put it in equation number 2. Why? Because equation number 2 defines the deflection. So when you put it in this equation, so EI into 0 is equal to minus 0.25 by 3 into 0 cube plus 3 into 0 minus 8 power square plus 3 into 0 minus 16 power 2 plus C1 into 0 plus C2. So we will get EI into 0 will be 0. This term will be 0. Now this term is 0 minus 8 is actually minus 8 inside the Macaulay bracket. So any negative term inside the Macaulay bracket will be considered as 0. So this term will be also 0. Similarly, this term minus 16 will be inside the Macaulay bracket will be 0 plus C1 into 0 is 0 plus C2. So it means that C2 will be equal to 0. Now we'll find C1 and we'll use another boundary condition. And what is that? So at x is equal to 24 feet, we have deflection is equal to 0. So let me show you over here. Now you can see that at this point, x is equal to 24 feet. And we have deflection is equal to 0 because there is a rolling support. Okay, so what we will do is that again you have to put in equation number 2. So when you put it in equation number 2, so EI into V, so V is equal to 0, so EI into 0 is equal to minus 0.25 by 3 into 24 power cube plus 3 into 24 minus 8 square plus 3 into 24 minus 16 square plus 24 C1 and C2 is equal to 0. So we will get this as a 0 is equal to minus 0.25 divided by 3 into 24 power 3 plus 3 into this will be 16 square plus 3 into 8 square plus 24 C1. And when you calculate all this using your calculator, so you will get C1 will be equal to 8. Now you have C1 and C2. So what you will do is that put value of C1 and C2 in equation number 2 to get the equation of elastic curve. So EI into V is equal to minus 0.25 divided by 3, which is equal to 0.0833 x cube plus 3 into x minus 8 power square plus 3 into x minus 16 square plus C1 is 8, so 8x. Clear? And when you, its unit will be, let me write the unit as well. So the unit will be kips into cubic feet. So if you divide EI on both sides, so you will get V is equal to 1 over EI into minus 0.0833 x cube plus 3 into x minus 8 square plus 3 into x minus 16 square plus 8x. Kips into feet. And this is the required equation of elastic curve for the beam and loading that's shown above. Now, some students ask that the unit of displacement, if it is in feet, so it should be feet. So why the unit is kips into feet? So if you put the unit of E and I, and they will cancel each other, and at the end you will get in answer in feet. So this was all about this problem 12-43. I hope you have enjoyed this video and you are learning from my videos as well. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest video which I post. If you have any question, you are welcome to ask in comment section. Thank you for watching. Welcome back. Problem 12-42. So this problem is taken from chapter number 12, that is deflection of beam and shaft, and the book name is Mechanics of Material by RC Hibbeler. So statement is the beam is subjected to the load shown. Determine the equation of elastic curve. EI is constant. So you can see this is overhanging beam having a roller support at point A and pin support at point B, and from over a distance of 1.5 meter there is a uniformly distributed load that is 6 kilonewton per meter and at this end we have a point load of 20 kilonewton per meter. So you have to determine the equation of elastic curve. So we'll solve this question by using Macaulay's method. So first what we will do is that if you remove this support at point A, so you will be having a reaction force, let this is RA, and if you remove this pin support at point B, so you will be having a reaction force which is RB. So we'll find this reaction force by using equation of equilibrium. So first equation of equilibrium is that sum of all moments about point A is equal to 0 and taking the counterclockwise movement as positive. So about point A, the first movement will be produced due to this distributed load, and this distributed load when converted into point load, so it will be 6 into 1.5, and the perpendicular distance will be 1.5 divided by 2, which is 0.75. So I will write if this uniformly distributed load is converted into point load, so 6 into the distance over which it acts, 1.5, which is equal to 9 kilonewton, and it will act at a distance of half of 1.5, which is 0.75 meter. Okay, and this is producing counterclockwise movement, so it will be positive. So I will write 9 into 0.75. The second movement that is produced at point A is this one, which is RB into perpendicular distance is 3, and this is producing counterclockwise movement, so it will be also positive. So plus RB into 3. The last movement that is produced by this 20 kilonewton and perpendicular distance is 4.5, and this is producing clockwise, so it will be negative. So I will write minus 20 into 4.5, and the sum of all this movement about point A must be equal to 0. So from here you will get 6.75 plus 3 times RB minus 90 is equal to 0. So what we will get is 3 RB will be equal to 83.25, and if you divide 3 on both sides, so you will get 83 divided by 83 divide 0.25 divided by 3 will give you 27.75 kilonewton. So this is the value of RB Now we'll find RA by using equation of equilibrium that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see one force which is -9 that is acting downward plus RA plus RB -20 will be equal to 0. So I will write from here, you can see -9 plus RA plus RB, which is 27.75 minus 20 will be equal to 0. And when you calculate it, you will get RA will be equal to 1.25 kilonewton. Now you have RA and RB, so we'll find equation of elastic curve, and you know that equation of elastic curve can be obtained by using this formula, which is EI into d square V over dx square is equal to movement. Since we are applying Macaulay's method, so what we will do is that you can see different scenarios. This is movement, this is for point load, this is for distributed load, and this is for triangular loads. And the moments equations are mentioned over here. Now you can see here you have a uniformly distributed load that starts from here. So our x starts from here, and you can see this is for a length of 1.5. But in this case of distributed load, the distributed load starts from any point, and it should be till the end. So what we will do is that we will add this till the end here, and with this we will also subtract the same at the bottom. So it will cancel the effect. So what we will do is that I will draw the free body diagram again. So we will take this uniformly distributed load till the last, and its magnitude is 6 kilonewton per meter, 6 kilonewton per meter. And this was point A where we have RA. So RA is 1.25 kilonewton, and here you have RB, which is 27.75 kilonewton. And in order to cancel the effect, what we will do is that we will add the same distributed load over this length in upward direction. So this length is 3 meter, this is 1.5 meter, and this is again 1.5 meter. And this will be also 6 kilonewton per meter. So what we have done is that we have added a distributed load over a length of 4.5 in downward direction, and we have also added 6 kilonewton per meter over a length of 4.5 meter in upward direction in order to cancel the effect. Now we'll apply this table to get our required moment equation. So I will write moment equation. So for first, this uniformly distributed load of 6 kilonewton. So you can see x starts from here. Here. And here in this case, for this load of 6 kilonewton, A is equal to 0. So moment equation is this one, which is W naught by 2. So W naught is 6. So 6 divided by 2 into x minus A. So A is equal to 0 because this load starts from this end. So x minus 0 power 2. The second load will be point load, which is 1.25. So for point load, you can see this is upward force. So moment will be this one. So plus RA, which is 1.25 into x minus A. A is 1.5. Minus 1.5. Now one more thing is that this uniformly distributed load is downward direction, and for plus moment it is upward, so this will be minus. Okay, the third one will be this uniformly distributed load, which is acting upward. Now this is acting at a distance of A from this end, so I will write the moment function will be plus W naught over 2. W naught is 6, so 6 over 2 into x minus A. A is 1.5 times square. Clear? And the last thing is 27.75 kilonewton. So plus 27.75. Why plus? Because you can see force is upward, so moment function will be positive. Into x minus. Now A will be equal to this distance. This is A for this load. This is A, and this A is 4.5. So I will write x minus 4.5 power 1. Okay. So if you further simplify this moment equation, it will be equal to minus 3x square plus 1.25 times x minus 1.5 plus 3 into x minus 1.5 square plus 27.75 into x minus 4.5. Now put this the value of m in this equation. So you will get E into I d square V over dx square will be equal to minus 3x square plus 1.25 times x minus 1.5 plus 3 into x minus 1.5 square plus 27.75 into x minus 4.5. So what we'll do is that integrate this equation, integrate it, you will get EI into dV over dx, where V is deflection, will be equal to minus 3x cube over 2 plus 1.25 times x minus 1.5 square divided by 2 plus 3 into x minus 1.5 power 3 divided by 3 plus 27.75 into x minus 4.5 power 2 divided by 2, and there will be a constant of integration C1. Let this is your equation number 1. Again integrate equation 1. So you will get EI into V, which is deflection, will be equal to minus 3x4 over 8 plus 1.25 into x minus 1.5 whole cube divided by 6 plus x minus 1.5 whole power 4 divided by 4. 3 will cancel. So 4 plus 27.75 into x minus 4.5 whole cube over 6 plus C1x plus C2. And this is your equation number 2. So if you further simplify it, you will get EI into V is equal to minus 0.25 x power 4 plus 0.208 into x minus 1.5 times cube plus 0.25 into x minus 1.5 whole power 4 plus 4.625 into x minus 4.5 times cube plus C1 into x plus C2, which is we will write this as equation 2 because this is the simplest. Okay, now C1 and C2 are unknown constant of integration, and we can find them by using boundary condition. So boundary conditions will be used to find C1 and C2. So what are the boundary conditions? So first boundary condition is at x is equal to 1.5, we have deflection is equal to 0. Let me show you here. You can see x is equal to 1.5, we have deflection is equal to 0 because there is a roller support. So what we will do is that put in equation 2, So what we will get, EI into 0 is equal to minus 0.25 into 1.5 power 4 plus 0.208 into 1.5 minus 1.5 power 3 plus 0.25 into 1.5 minus 1.5 power 4 plus 4.625 into 1.5 minus 4.5 power 3 plus 1.5 x, sorry, C1 into x. So x is 1.5, C1 plus C2 will be equal to this one. So from here, this is equal to 0, and this term will be minus 1.266, this term will be 0, this term will be 0, and this term will be also 0, because 1.5 minus 4.5 is minus 3, so anything that is negative inside the Macaulay bracket will be 0. So this will be plus 1.5 C1 plus C2. So from here, you will get this equation is 1.5 C1 plus C2 is equal to 1.266. Let this is your equation number 3. Now the second boundary condition is that at x is equal to 4.5, we have deflection is equal to 0. So let me show you here, x is equal to 4.5 and we have deflection is equal to 0 because there is a pin support. So what will that put in equation number 2 again? So EI into V is 0, which is deflection, is equal to minus 0.25 into 4.5 power 4 plus 0.208 into 4.5 minus 1.5 power 3 plus 0.25 into 4.5 minus 1.5 power 4 plus 4.625 into 4.5 minus 4.5 whole power cube plus C1 into x. So x is 4.5, so C 4.5 into C1 plus C2. So 0 is equal to minus 102.516 will be this value, plus 5.625 when you calculate it will be this value, and this value will be plus 20.25, and this will be 0 plus 4.5 C1 plus C2. So from here you will get 4.5 C1 plus C2 will be equal to 76.641. That this is your equation number 4. Now equation 3 and 4 are simultaneous equation. So solve equation 3 and 4 simultaneously. It's very easy. You will get C1 will be equal to 21.52 and C2 will be equal to minus 36.42. So this is the value of C1 and C2. Now put C1 and C2 in equation number 2 to get the equation of elastic curve. So when you put it, you will get V will be equal to V is equal to 1 over EI into minus 0.25 x power 4 plus 0.208 into x minus 1.5 whole cube plus 0.25 into x minus 1.5 power 4 plus 4.625 into x minus 4.5 power cube plus C1x. So C1 is 21.52 x minus C2. C2 is minus 36.42. Okay, so again, if kindly make a correction over here that this C1 is 25.12, and so C2 is okay. So this is 25.12, and this is your required equation of elastic curve for the loading. So if you want to have deflection at any instant of x, so put the value of x over here, so you will get the, and if you know E and I, so you will get the deflection at that length of the beam due to the loading. And that was all about this problem 12-42. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also check the description box where I have mentioned all the links of all the chapter playlists where you will find different problems that is explained in a very easy and simple manner. If you have any question, you can ask me in comment section. Thank you for watching. Welcome back. Problem 12-44. This problem is taken from chapter number 12, that is deflection of beam and shaft, and book name is Mechanics of Material by RC Hibbeler. So statement is the beam is subjected to the load shown. Determine the equation of elastic curve. EI is constant. So you can see this is overhanging beam where there is a roller support at point A and a pin support at point B. At this end we have a load of 20 kilonewton, and at other end we have a load of 20 kilonewton. So you have to determine the equation of elastic curve. So basically we will solve this question by using this discontinuity function or Macaulay's method. So let's start with the solution. So first step is that if you remove this support at point A, so you will be having a reaction force which is represented as RA, and if you remove this pin support at point B, so you'll be having a reaction force as RB. So we'll find this RA and RB by using equation of equilibrium. So first equation of equilibrium is sum of all moments about point A is equal to 0, taking the counterclockwise movement as positive. So about point A, first movement is this 20 into perpendicular distance is 1.5, and this is producing counterclockwise movement, so it will be positive. So I will write it 20 into 1.5. The second movement that is produced due to this RB about point A is this RB into perpendicular distance is 3, and this is producing counterclockwise, so it will be also positive. So I will write plus RB into perpendicular distance is 3. The last movement that is produced due to this 20 kilonewton force about point A is force into perpendicular distance is 4.5, and this is producing counterclockwise movement, so it will be negative. So I will write minus 20 into 4.5 is equal to 0. So here we will get 3RB plus 30, 20 into 1.5 is 30, and this will be minus 90 is equal to 0. So 3RB will be equal to, this will be minus 60, so it will be 60. So from here you will get RB will be equal to 20 kilonewton. So this is RB. Now we'll find RA by using another equation of equilibrium, that is sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So you can see one force, this is plus 20 plus RA plus RB minus 20. So this is also minus 20 because this is downward. So minus 20 plus RA plus RB, which is equal to 20, and minus 20 is equal to 0. So from here you will get RA will be also equal to 20 kilonewton. Now you have both RA and RB. So what we will do is that we will find equation of elastic curve, and we know that equation of elastic curve can be obtained by using this formula EI into d square V over dx square, where V is deflection and x is the distance that starts from here, is equal to moment. So we will find this moment by using Macaulay's method. So by using discontinuity functions are Macaulay's method. And for that, you can see this is the table that is available in chapter number 12, deflection of beam and shaft. So for that, I will write the equation of moment. This moment is equal to, now you can see here we have loadings. So this is first, second, third, and fourth, 4 different type of loading. So in our case, we can see all the loads are points loads. So what we will do is that we will use case number 2. So moving from right hand side, we will count all these forces, this, and this, and we will leave this one on the left. This is the right hand side, and this is left hand side. So moving from left to right hand side, we will neglect this 20 kilonewton, and we will include all these forces. Now you can see this force is upward, and moment equation is defined by this, and this force x at a distance of a, and x start from here. So x is again start from here. For this loading, a will be equal to 0. So I will write, and this force is downward while this force is upward. So moment is positive. So for downward, it will be minus p, which is 20 into x minus a is 0 power 1. Second force is RA, that is acting upward. So this will be plus RA is 20 kilonewton, so 20 into x minus a. Now a is equal to 1.5 for RA load. So my x minus 1.5 power 1. And the third one is RB, and that is also positive because it is upward, so moment equation will be positive. So RB is 20 into x minus a. So a for RB will be equal to 1.5 plus 3, which is 4.5 power 1. So what we will get is the moment equation will be minus 20 into x plus 20 into x minus 1.5 plus 20 into x minus 4.5. Now let this is your equation number A. So put value of m in equation number A. So we will get EI into d square V over dx square will be equal to minus 20x plus 20 into x minus 1.5 plus 20 into x minus 4.5. What we will do is that integrate this equation. You will get EI into dV over dx will be equal to minus 20x square over 2 plus 20 into x minus 1.5 power 2 divided by 2 plus 20 into x minus 4.5 power 2 divided by 2. So we will get EI into dV over dx will be equal to minus 10x square plus 10 into x minus 1.5 square plus 10 into x minus 4.5 square, and there will be a constant of integration C1, so C1 will be also there. Let this is your equation number 1. So again integrate equation 1. We will get EI into V, which is deflection or displacement, minus 10x cube by 3 plus 10 into x minus 1.5 power 3 divided by 3 plus 10 into x minus 4.5 square cube divided by 3 plus C1x plus C2. That this is your equation number 2. Now we can see that C1 and C2 are unknown constant of integration. So using boundary conditions to find out C1 and C2. So first boundary condition is that at x is equal to 1.5, or you can also at x is equal to 1.5 we have displacement is equal to 0. So what we will do is that I will show you here x is equal to 1.5 we have displacement or deflection is equal to 0 because there is a roller support at point A. So what we will do is we will put in equation number 2. Put it in equation 2. So you will get EI into 0 is equal to minus 10 into 1.5 cube divided by 3 plus 10 divided by 3 into 1.5 minus 1.5 whole cube plus 10 divided by 3 into 1.5 minus 4.5 whole cube plus C1 into 1.5, so it will be 1.5 C1 plus C2. So it will be equal to 0, and this will be again minus 10 by 3 into 1.5 cube plus this term will be 0. This term will be minus 3, and anything inside the Macaulay bracket that is minus will be 0 also. So 0 plus 1.5 C1 plus C2. So what we will get, so we will get 0 is equal to minus 10 divided by 3 into 1.5, you can simplify it as well, plus 1.5 C1 plus C2. That this is your equation number 3. Now second boundary condition is that at x is equal to 3 meter, you have dV over dx, which is equal to slope will be equal to 0. So let me show you over here. So due to this loading, the beam will bend like this here. So here you can see this is the distance where x is equal to 3. And here you can see if you take the tangent to this curve, so its slope dV over dx will be equal to 0. So what we will do is that put it in equation 1. So this is equation 1. So if you put it in equation number 1, so you will get EI into dV over dx is equal to 0, and that is minus 10 into 3 square plus 10 into 3 minus 1.5 square plus 10 into 3 minus 4.5 square plus C1. So 0 is equal to minus 10 into 9 plus 10 into 1.5 square, and this term will be 0 because 3 minus 4.5 is minus 1.5 inside the Macaulay bracket, and that will be 0. 0 plus C1. So from here when you calculate it, you will get C1 is 67.5. Now you have C1, so put the value of C1 in equation number 3. So you will get C2, and C2 will be equal to minus 90. Now you have C1 and C2, so we are interested to find out the equation of elastic curve, and this equation number 2 defines it. So what we will do is that we will put the value of C1 and C2 in equation number 2. So you will get EI into V is equal to minus 10 times x cube over 3 plus 10 by 3 into x minus 1.5 whole cube plus 10 by 3 into x minus 4.5 cube plus C1, which is 67.5x, plus C2 is minus 90. So I will correct it. This is minus 90. And if you divide EI on both sides, so you will get V is equal to 1 over EI into minus 10 x cube over 3 plus 10 by 3 into x minus 1.5 whole cube plus 10 by 3 into x minus 4.5 whole cube plus 67.5x minus 90. And its unit will be kilonewton into cubic meter. And what if you have E and I? So put their units. So at the end you will get the V unit will be in meter, or you can convert it into millimeter. So that is the answer or equation of elastic curve for the given loading shown above. And that was all about this problem 12-44. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 12-45, and this problem is taken from chapter number 12, Deflection of Beam and Shaft, and book name is Mechanics of Material by RC Hibbeler. So statement is, determine the deflection at each of the pulleys C, D, and E. The shaft is made of steel and having diameter of 30 mm. The bearing at A and B exert only vertical reaction on the shaft, and E of steel is 200 GPa. So you can see this is the shaft where pulley C, D, and E exert force of 150 Newton, 60 Newton, and 150 Newton respectively. And this is the bearing at point A and B, which exert only vertical reaction force. So you have to determine, due to this loading, it will deflect like this. So you have to find deflection of C, deflection of D, and deflection of this E. So let's start with the solution. So when you remove this bearing at point A, so you'll be having a reaction force that will be acting down upwards. So this is RA, and if you remove this bearing at point B, so there will be a reaction force which is represented as RB. So we'll find this RA and RB using equation of equilibrium. So first equation of equilibrium is that sum of all moments about point A is equal to 0, taking the counterclockwise moment as positive. So about point A, one moment is due to 150 no load into perpendicular distance, which is 250 millimeters. So in meter it is 0.250 meter, and this is clockwise, so it will be negative. The second moment will be this 160 into perpendicular distance is now 500 millimeter, which is 0.5 meter, and this is also clockwise, so it will be negative. The third moment will be this 150 Newton and perpendicular distance is 750 millimeter, which is 0.750 meter, and this is also clockwise, so it will be negative. The last moment will be due to this force into perpendicular distance is 1000 millimeter, which is 1 meter. And this is producing counterclockwise, so it will be positive. And the sum of all these moments about point A will be equal to 0. So I will write minus 150 into 0.250 minus 60 into 0.5 meter minus 150 into 0.750 meter plus RB into 1 will be equal to 0. So when you calculate it, you will get this RB will be equal to 180 Newton. Okay. So now we'll find this RA by using another equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So RA is upward, so RA minus 150 plus 60 plus 150, minus 150, minus 60 and minus 150, minus 60 minus 150 plus 180 is equal to 0. So you will get RA will be equal to, again this will be, the unit is Newton. So RA will be also 180 Newton, because 150, 150 is 300, 360 minus 360 plus 180 will be 180. So now you have RA and RB. So what we will do is that we will find equation of elastic curve, because we have to find deflection. So for that we need equation of elastic curve that can be obtained by using this equation moment, and we will find this moment by using singularity function. M can be found by using singularity functions, or you can also say it as Macaulay's method. So for that we need table that is available in the chapter number 12. So I will copy it from the previous problem which I have solved. So let me copy it and we will paste it over here. So you can see here all the loadings are points loading. So you can see these are the points load. So we'll start from the left hand side and we will count each force except this one. We will ignore right hand side. So this is the loading for point loading, and the moment equation is this one. The load is upward, so moment is positive. So I will write moment. The first force is RA, which is 180, and this is upward, so this moment will be positive. So RA is 180 into x minus A. A is 0 for RA, so x minus 0 power 1. Now we'll move toward second force, which is minus 150. So this moment will be negative, because here the moment is positive for upward, so for downward force it will be minus. So 150 into x minus, now A is 250. So 250 meter is 0.25 power 1. The third force is 60 Newton, so that is downward, so minus 60 into x minus A will be for that 500, so which is 0.5. And the fourth force is 150, that is also downwards, 150 minus 150 into x minus A is now 750 millimeter, which is 0.75. And we will neglect the last term. So this is the moment equation. This is your equation number A. So what we'll do is that put value of M in equation A. So you will get E into I, d square V over dx square will be equal to 180 into x minus 150 into x minus 0.25 minus 60 into x minus 0.5 minus 150 into x minus 0.75. So integrate this equation, integrate it, you will get EI into dV over dx will be equal to 180 x square over 2, which is 90 x square, minus 150 into x minus 0.25 whole square divided by 2. So 150 divided by 2 is 75. So it is x minus 0.25 power 2. And this will be minus 30 into x minus 0.5 power 2. And this will be minus 150 into x minus 0.75 divided by 2. So again, this will be minus 75 into x minus 0.75 power 2. Plus there is a constant of integration, which is C1. Let this is your equation number 1. What we will do is next is again integrate equation 1. So you will get EI into V is equal to 90x cube divided by 3, which will be 30x cube minus 75 into x minus 0.25 whole cube divided by 3, and that will be equal to 25 into x minus 0.25 whole cube minus 30 into x minus 0.5 whole cube divided by 3, which is equal to 10 into x minus 0.25 whole cube, and this will be equal to 75 minus 75 will be 75 divided by 3 will be 25, so 25 into x minus 0.75 whole cube plus C1x plus C2. That this is your equation number 2. Now C1 and C2 are unknown constant of integration, so we will use boundary conditions. Will be used for finding C1 and C2. So first boundary condition is that at x is equal to 0, we have deflection is equal to 0. So let me show you over here. You can see at point A here, x is equal to 0. So we have deflection is equal to 0 because there is general bearing or support. So put in equation 2. So we will get EI into 0. And this will be equal to 30 into 0 cube minus 25 into 0 minus 0.25 cube minus 10 into 0 minus 0.25 whole cube minus 25 into x minus 0.75 whole cube, x is 0, plus C1 into 0 will be 0 plus C2. So you can see that this will be equal to 0 and this will be also 0 minus 0 minus 0.25, and that is inside the Macaulay bracket. So anything that is negative inside the Macaulay bracket will be 0. Similarly, this will be 0, this will be 0. So it means that C2 will be equal to 0. Now you have C2 is equal to 0. We will use another boundary condition, and that boundary condition is that at x is equal to 1000 millimeter, that is equal to 0.1 meter, we have deflection is equal to 0. So let me show you here. You can see x is 1000 millimeter, that is 0.1 meter. We have deflection is equal to 0 because there is a bearing or support at point B. So what we will do is that put in equation number 2. Let me show you. This is equation number 2. So I will write EI into 0 is equal to 30 into 0.1. Okay, 1000 meter is 1 meter. 1000 millimeter is 1 meter. Let me correct it over here. So that is 1 meter. So 30 into 1 minus 25 into 1 minus 0.25 whole cube minus 10 into 1 minus 0.25. Let me check it over here. Okay, I had a mistake. You can see this is 0.25. So this is 0.5. So this is 0. Correct it. This is 0.5. So this was also 0.5, but that is negative. Okay, so 1 minus 0.5 cube minus 25 into 1 minus 0.75 whole cube plus C1 into 1, which is C1. Okay, now it's clear. So we will get 0 is equal to 30, and this term will give you 1 minus 0.75 will be 0.75 whole cube, and this will give you minus 10.55 minus this term will give you, when you calculate it, will be 1.25, and this term will give you, this whole term will give you minus 0.39 plus C1. So from here you will get C1 will be equal to minus 17.8125. Now you have C1 and C2. What will that is put value of C1 and C2 in equation number 2. So you will get EI into V is equal to 30x cube minus 25 into x minus 0.25 whole cube minus 10 into x minus 0.5 whole cube minus 25 into x minus 0.75 whole cube plus C1 is minus 17.81 into x plus C2 is 0. And if you divide this equation by EI on both sides, so what we will get is that we will get this term divided by EI. And that is your required equation of elastic curve. Now we will move to find VC, deflection at C, D, and E. So for VC, we have x is equal to 0.25 meter. So first we will find VC. So VC will be at x is equal to 0.250 meter. So put it in this, let this is equation B. Put in equation B. So you will get VC is equal to deflection at x is equal to 0.25, clear? And that will be equal to 30 multiplied by 0.25 cube minus 25 into 0.25 minus 0.25 whole cube minus 10 into 0.25 minus 0.5 whole cube minus 25 into x minus 0.75. X will be replaced with 0.250 minus 0.75 whole cube minus 17.81 into 0.25. Divide by E into I. So the value of E is given as E for steel is 200 gigapascal and diameter is given. So 200 into 10 to the power 9. And I for this circular pipe is pi by 4 r power 4. So diameter is given as 30 millimeter. So radius will be equal to 15 millimeter. So and meter is 0.0150. So 0.015 power 4. So this term will be 0. This term is negative, so anything inside the Macaulay bracket that is negative will be 0. This term will be 0. So we're left with this term and this term. And when you divide it, you will get VC is equal to V at x is equal to 0.25 will be equal to minus 0.000501 meter. Or you can say that deflection at pulley C will be equal to minus 0.0001. So it will be minus 0.5 in millimeter. It is 0.501 millimeter. And you can also 0.501 millimeter, and the deflection negative means deflection is downward. So this is deflection at point C. Now we will move toward point deflection at pulley B, D. So x will be equal to 0.50 meter. So we will find deflection. Vd at x is equal to 0.5 meter. So V is put the value put in equation number B. So you will get VB is equal to V at x is 0.5 will be equal to, you can just put the value. I will put 130 into 0.5 whole cube minus 25 into 0.5 minus 25 0.25 whole cube minus 10 into 0.5 minus 0.5 whole cube and minus 25 into 0.5 minus 0.75 whole cube minus 17.81 into 0.5 divide by whole. We will divide it by E into I. So E is 200 gigapascal, so 200 into 10 to the power 9, and I for circular rod is pi by 4 R4, so R is 0.015 power 4. So when you solve this, you will get VB is equal to minus 0.000698 meter, or you can say minus 0.698 millimeter, or 0.698 millimeter, and that is downward. So this is the deflection at point B. What we can do is that we have to find deflection at point E. So here x is equal to 0.75 meter. So what we will do is that VE is equal to V at x is 0.75 will be equal to, you can just put the value, this is your assignment, you can just put x is equal to 0.5 over here, divided by EI, and you can calculate V, that will be minus 0.501 millimeter, or you can see 0.501 millimeter, that is downward. So negative sign means that deflection is downward. You can easily solve this last part, just put the value, and I hope that you will solve it. And that was all about this problem 12-45. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also, the links of all playlists is present in the description box, so you can go and click your desired chapter and you will get all the problems of that chapter. Thank you for watching. Welcome back. In this video, we are going to solve problem 12-46 that is taken from chapter number 12, Deflection of Beam and Shaft. And the book name is Mechanics of Material by RC Hibbeler. So statement is determine the slope of shaft at the bearing at A and B. The shaft is made of steel and having diameter 30 mm. The bearing at A and B exert only vertical reaction on the shaft. E of this shaft is 200 gigapascal. So this is a shaft having support at A and B by using a bearing that exert only vertical reaction force, and the load at point C, D, and E of the pulley is shown over here. So due to this loading, the shaft will bend like this. So what we have to find? We have to find the slope at A and slope at B. What is slope? So tangent to this curve will define the slope. Clear? So we have to find the slope at A and B. So let's start with the solution. The first step will be, if we remove this bearing at point A, so you will be having a reaction force. Let this is RA, and if you remove this bearing at point B, so you will be having a reaction force that is represented by RB. So we'll find RA and RB by using equation of equilibrium. So first equation of equilibrium, that sum of all moments about point B is equal to 0, and taking the counterclockwise moment as positive. So about point B, first moment will be this 150 into perpendicular distance, which is 250 millimeter, and in meter it is 0.250 meter, and this is producing counterclockwise moment, it will be positive. The second moment that will be produced due to this 60 Newton force, and perpendicular distance is now 500 millimeter, which is equal to 0.500, and this is also producing counterclockwise, so it will be positive. The third moment will be this one, and perpendicular distance is 0.750 meter, and this is also counterclockwise, so it will be positive. And the last moment due to RA into perpendicular distance is now 1000 millimeter, or it is 1 meter, and this is producing clockwise, so it will be negative. And the sum of all these moments about point B will be 0. So I will write 150 into perpendicular distance is 0.250 plus 60 into 500, which is 0.500 meter, plus 150 into 0.750 meter, and minus RA into 1 is equal to 0. So when you calculate it, you will get RA will be equal to 180 Newton. So this is your RA. We can find RB as well by using this equation of equilibrium, that sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So RA is upward, so 180. This force is downward, so minus 150. This force is downward, which is minus 60, minus this force, which is 150, plus RB is equal to 0. So from here you will get 150, so 180 minus 360 plus RB is equal to 0. So it means that RB is equal to 180 Newton. Now we have RA and RB, so we'll move toward finding the equation of elastic curve that can be obtained by using this equation. EI into d square V over dx square is equal to moment, and this moment can be obtained by using Macaulay's method or singularity functions. So we'll find this M as well. So I will write the M moment. Now you can see all the loadings are point loads at A, C, D, and E, and there is a table that is shown for the point load, that is serial number 2. So for point load, the moment function is defined by this equation, and this point P is upward, so it will be positive, and this is acting at a distance of A, and X start from this distance. So we'll start for RA. So for RA, A is equal to 0, and X is starting from this point. So I will write, since force is upward, so I will write RA, which is equal to 180 into x minus A. A is 0, so x minus 0. And the second force is 150 Newton, that is downward, so I will write minus 150 into x minus A will be 250 millimeter, which is 0.25 meter. The third force is 60 Newton, so it will be minus 60 into x minus 0.5. And the other force is 150, so minus 150 into x minus 0.75. And we will neglect the force on the right hand side. So this is your moment equation. Now this is your equation number A. So put value of m in equation number A. So what we will get is that EI into y, EI into d square v over dx square will be equal to 180 into x minus 150 into x minus 0.25 minus 60 into x minus 0.5 minus 150 into x minus 0.75. So integrate this equation. What we will get EI into dv over dx will be equal to 180 square, 180 x square over 2 minus 150 into x minus 0.25 square divided by 2 minus 60 into x minus 0.5 square divided by 2 minus 150 into x minus 0.75 square divided by 2, plus there will be a constant of integration, which is C1. So this will be equal to EI into dv over dx will be equal to 90x square minus 75 into x minus 0.25 square minus 30 into x minus 0.5 square minus 75 into x minus 0.75 square plus C1. Let this is your equation number 1. So what we will do is that integrate equation number 1. So you will get EI into V will be equal to 90x cube over 3 minus 75 into x minus 0.25 whole cube over 3 minus 30 into x minus 0.5 whole cube over 3 minus 75 into x minus 0.75 whole cube divided by 3 plus C1x plus C2. And if you further simplify it, you will get EI into V is equal to 30x cube minus 25 into x minus 0.25 whole cube minus 10 into x minus 0.5 whole cube minus 25 into x minus 0.75 whole cube plus C1x plus C2. And this is your equation number 2. Now we can find C1 and C2 by using boundary conditions. So I will write boundary conditions for that. So first boundary condition is that at x is equal to 0, we have V deflection is equal to 0. So let me show you over here, x is equal to 0, we have deflection is equal to 0. So what we will do is that we will put in equation number 2, because equation number 2 is for deflection. So here EI into 0 is equal to 0, and you can see that this term will be 0 because x is equal to 0. This will be minus 0.25, and anything inside Macaulay bracket that is negative will be 0. So this will be 0, this will be 0, and C1 into 0 will be 0, and only left with C2. So that is equal to C2. So from here you can say that C2 is equal to 0. Now we will use another boundary condition, and what is that? So at x is equal to 1 meter, we have deflection is equal to 0. So here x is equal to 1000 millimeter or 1 meter. So here you have deflection is equal to 0 because at point B we have a bearing support. So put in equation 2, that is about deflection. So EI into 0 is equal to 30 into 1 cube minus 25 into 1 minus 0.25 whole cube minus 10 into 1 minus 0.5 whole cube minus 25 into 1 minus 0.75 whole cube plus C1, which is C1 into 1, and C2 is equal to 0. So you will get 0 will be equal to 30 minus 10.55 minus 1.25 minus 0.39 plus C1. So here if you calculate it, you will get C1 will be equal to minus 17.8125. Now you have C1 and C2. So put value of C1 and C2 in equation number 1. Why equation number 1? Because equation number 1 defines the slope, and we have been asked to find the slope at point A and B. So we will put it in equation number 1. So we will get EI into dV over dx, which is equal to slope, and that is 90 into x square minus 75 into x minus 0.25 whole square minus 30 into x minus 0.5 square minus 75 into x minus 0.75, and C1 is minus 17.8125. And when you divide EI on both sides, so you will get dV over dx, that is equal to slope, and that will be equal to 1 over E times I into 90x square minus 75 into x minus 0.25 whole square minus 30 into x minus 0.5 square minus 75 into x minus 0.75 and minus 17.8125. Now slope at A is not known, and this slope is at x is equal to 0. So here you can see that x is equal to 0. We have to find slope at point A. So what we will do, we'll put x is equal to 0 in this equation. So let this equation is equation number B. So put x is equal to 0 in equation B. So you will get slope at x is equal to 0 will be equal to theta A, and that will be equal to 1 over E into I, and 90 0 square minus 75 into 0 minus 0.25 square minus 30 into 0 minus 0.5 square minus 75 into 0 minus 0.75 square. This is square. Let me check it. This is square. Okay. Minus 17.8125. So this value will be 0. This will be also 0 because minus 0.25 inside the Macaulay bracket is 0. This will be 0, this will be 0, and we will left with equal to theta A will be equal to minus 17.8125 divided by E into I. Minus 17.8125 E is given as 200 gigapascals, so 200 into 10 to the power 9. Let me show you over here. E is 200, and radius is of this shaft is 0.015. So I for circular shaft is pi by 4 r power 4. So pi by 4 r is 0.015 power 4. So again, when you calculate it, you will get this will be equal to minus 0.00224 radian. And we know that 2 pi radian is equal to 360 degree. So 1 radian is equal to 360 divided by 2 pi is again equal to 180 divided by pi. So multiply this 0 point theta A will be equal to minus 0.00224 into 180 degree divided by pi, and that will be equal to minus 0.128 degree. So this is the slope at point A. Next slope at point B, which is equal to theta B, and theta B is at x is equal to 1 meter. So here you can see theta x is equal to 1, theta B will be. So put the value in, put in equation B. So I will write it, theta B is equal to 1 over E into I into 90 into 1 square minus 75 into x minus x is 1 minus 0.25 square minus 30 into 1 minus 0.5 square minus 75 into x is 1 into 1 minus 0.75 whole square minus 17.1825. And when you put the value, that will give you 17.1825 divided by EI. So E is 200 gigapascal, 200 into 10 to the power 9 multiplied by I is pi by 4, r power 4, which is 0.015 power 4. So again, when you calculate it, it will be equal to plus 0.00224 radian. And you can say that if you want to convert it into degrees, so you have to multiply it with 180 by pi. So you will get the angle will be equal to 0.128 degree. So this is plus value and this is minus. So this minus means this is clockwise. I will write clockwise, and this will be counterclockwise direction. So if I show you over here, let this is the angle. So this angle will be equal to, this will be equal to theta A, that is minus 0.128 degree clockwise, and this one will be counterclockwise, will be theta B, and that is 0.128. And that was all about this problem 12-46. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.